Hey, welcome to The Explainer. Today, we are diving into a piece of tech that could honestly change everything we know about medical testing. We're talking about a way to diagnose a super common virus in just 9 minutes for about $1. Yeah, you heard that right. So let's break down how this thing actually works and what it could mean for all of us.
Let's just start with a thought experiment. What if getting a really important medical test was as simple and private as a home pregnancy test? Something fast, incredibly cheap, and you could do it literally anywhere. Imagine getting answers that matter, not in days, but in just a few minutes. Well, that's the world this new technology is promising to create.
So, to really get why this is such a big deal, let's zoom in on one very, very common virus, herpes simplex, or HSV. Right now, if you want to get tested for it, you're faced with this series of not-so-great choices. And the biggest cost you pay? Well, it isn't always in dollars. It's in the time you spend just waiting and worrying. Okay, so look at the options we have today. None of them are perfect, right? You've got the super accurate lab-based PCR test, but it's pricey and it takes a while. Then there are blood tests like ELISA, but a lot of the time they just tell you if you've had it in the past, not if you have an active infection right now. And the old school viral culture, that's usually the slowest of them all. You're basically forced to pick your poison. Do you want speed, low cost, or accuracy? Because you can't have all three.
And this is way more than just some bars on a chart. This is about the real human cost of waiting. Sure, a PCR test might only take a couple of hours in the lab itself, but that's after your sample gets all the way there. And a viral culture? That can leave you in total limbo for up to 3 days. That's 72 hours of just pure anxiety waiting for news that could totally change your life. So what's the answer to this whole mess of speed versus cost? Well, it's this little thing right here. The Nectin-1 electrochemical biosensor. This is the hero of our story. It's a breakthrough that's designed to make all those painful trade-offs we just talked about completely obsolete.
Okay, get ready. Here is the first number that changes the entire game: 9 minutes. Just let that sink in for a second. We went from a 72-hour wait down to a few hours for a PCR test. And now, this device gives you an answer in less time than it takes to brew a pot of coffee. It just completely erases that agonizing waiting period. Days of uncertainty just collapsed into a single moment. And if 9 minutes wasn't wild enough for you, here comes the second number: $1. That's what they think it'll cost to make one of the disposable test strips. We're talking about going from tests that can cost you anywhere from $80 to over $200 down to something that costs less than a bottle of water. This isn't just a small improvement. It's about making diagnostics available to literally everyone. So when you put it all side by side, the difference is it's night and day. We're moving away from this whole system that needs a special clinic, a centralized lab, a ton of money, and a long, anxious wait. And we're moving towards something that's portable, instant, and radically affordable. This isn't just a step forward. It's a giant leap into a whole new way of thinking about healthcare.
So how on earth does it work, this magic? Well, the science is actually incredibly elegant. Think of it like a lock and key. The sensor strip is coated with a special protein called Nectin-1. Now, the herpes virus itself has a protein on its outer shell that's a very specific shape. That's our lock. And it turns out, Nectin-1 is the one and only perfect key. So when the virus is present in a sample, it literally clicks into place on the sensor. That physical connection is all it takes to change the electrical current on the strip. And a little handheld reader can spot that change instantly. It's beautiful. No labs, no complicated steps, just a perfect molecular handshake. When you hear about a breakthrough this big, you probably picture some massive, multi-million-dollar government research facility, right? But what if I told you that you could build a working prototype for about the same price as a new laptop? Let's take a look at the shopping list. What's so amazing about this is that the parts are all things you can just buy. They're commercially available. You can order the disposable carbon electrode strips online. You can buy the special Nectin-1 bioreceptor and the other chemicals you need. And you can get a standard handheld reader that's designed to measure these tiny electrical signals. Nothing here is some crazy custom-built, one-of-a-kind machine. And here it is, the grand total. All in, you could put together a fully functional prototype for about $1,150.
Now, this is so important. This shows that game-changing medical innovation doesn't have to come from giant corporations with billions in R&D. When the price to just try out a new idea is this low, amazing things can happen anywhere. And progress can move at a speed we've just never seen before. Okay, so it's cheap to build, we got that. But how does this actually go from being a cool experiment on a lab bench to something a doctor can use? Or maybe even something you could buy at a pharmacy? Well, the researchers have a super clear, very practical plan. This isn't just a pipe dream, there's a real roadmap to get there. And the plan is just very logical, very methodical. First, you assemble the strips and start testing them with real-world samples to see how they do. Next, you program the little reader, and you can do this with open-source tools, which is awesome. Then the big one, you validate it with different kinds of samples, like saliva or urine, to make sure it works just as well. And the final step is starting that formal regulatory process, proving it's just as good as the gold standard PCR test. It's a clear, achievable plan. Because this thing is so sensitive, it opens up a whole new world of easy, non-invasive testing. We're talking about a future where you could just use a simple saliva swab, or a urine sample, or even a swab you collect yourself at home. No needles, no clinic visits, no mailing anything. You could get a definitive result right then and there. This is where diagnostics become truly powerful and personal. And the reason all of this is even possible comes down to how incredibly efficient the device is. The researchers themselves say it. The device needs only 10 microliters of fluid and a 5-minute incubation. Now, 10 microliters, that is a minuscule, tiny drop. And a 5-minute wait is nothing. That kind of efficiency is exactly what makes at-home instant testing a very, very real possibility. And that really brings us to the final and honestly the most exciting question of all. Remember that lock and key thing we talked about? This biosensor works because it has the specific, unique key for the HSV virus. But what happens when we start making new keys for different locks? If we can do this for herpes, what's stopping us from creating a $1 9-minute test for the flu, for strep throat, for COVID, or who knows how many other diseases? The basic platform is there. It's been proven. The potential from here, it's almost limitless. Thanks for joining us on The Explainer.